You ever look at a sequence of numbers and wonder, hey, is there a shortcut to find the millionth one without writing them all out? Well, you're in luck, because there is. Today, we're going to unlock the secret to predicting any number in a simple pattern by mastering something called an arithmetic progression. So to get our heads around this, just picture a ladder that stretches up forever. Each step, each rung is the exact same distance apart. The question is, how high up would you be when you got to the 100th step? Now that sounds like a crazy climb, but the math behind it? It's actually way simpler than you think once you know the trick. And that whole secret really just boils down to one core idea. This idea of a constant climb. Seriously, if you can get this one principle, everything else just clicks into place. Now, in the math world, this constant climb has a fancy name, an arithmetic progression. But don't let the name scare you. All it means is that you've got a list of numbers where the jump from one to the next is always, and I mean always, the same. It doesn't matter if you're going up or down, that step size never ever changes.
That's pretty much the whole story. The rule is super simple. You pick a starting number, and then you just keep adding, or maybe subtracting, the exact same amount over and over again to get to the next number. It's predictable, it's steady, and honestly, that's what makes it so powerful.
All right, so we get the basic concept, right? Now let's learn how to speak the language of these patterns so we can really start decoding them.
This table right here is basically our decoder ring. See, in math, we love using letters as shortcuts. So A is just our first term. Think of it as the very first step on the ladder where you start. D is the common difference. That's the height of each and every step. Then you have N, which is the position we're trying to find, like the 100th step. And finally, U_N. That's the prize. That's the actual value we're looking for, the total height once you get to that step. Okay, so we've got all of our pieces. Now it's time to assemble them into our incredible prediction formula. This is the tool, the powerhouse, that's going to let us calculate the value of any step in the sequence, no matter how far down the line it is.
And boom, there it is. UN equals A plus, in parentheses, N minus 1 times D. This little equation is our golden ticket. It's the ultimate shortcut that lets us jump straight to any number we want without having to calculate all the ones before it. Now you might be looking at that N minus 1 part and thinking, wait, why not just N? And that's a fantastic question. This is the key right here. Think about it. To get to the 20th step, you're already standing on the first one, so you don't need to take 20 jumps. You only need to take 19 jumps. More jumps to get there. The number of jumps is always one less than the step you're trying to reach.
All right, enough theory. The absolute best way to really get this is to see it in action. So let's put this formula to the test with a real-world example.
So here's our mission. Find the 20th term of this sequence, 5, 11, 17, 23, and so on. Right now, that 20th number is a total mystery, but we have everything we need to solve it.
First things first, we got to pull out our variables from the sequence. Our starting term, A, that's easy, it's 5. The common difference, D, well, what's the jump between the numbers? From 5 to 11 is 6, from 11 to 17 is also 6. Yep, looks like our D is 6. And finally, the position we're hunting for, N, is 20. Now for the fun part. We just plug those numbers right into our formula. So we start with our first term, 5, and we're going to add the result of 20 minus 1 times 6. First, let's handle the parentheses. 20 minus 1 is 19. That means 19 jumps. Now we multiply those 19 jumps by our step size of 6, which gets us 111. And for the grand finale, we add that to where we started, which was 5.
And that gives us our answer, 119. The 20th number in that sequence is 119. And we figured that out in, a few seconds? Without having to write out every single number along the way? That is the power of this formula.
So just like that, we found our answer. But look, this isn't just some neat math trick for a test. It's worth asking, why does this stuff actually matter? Where do we see these kinds of patterns in the real world?
Well, the truth is, these steady, predictable patterns are everywhere. Seriously. Think about putting the same amount of money into a savings account every single month. Or think about a car that loses a fixed amount of its value each year. This formula becomes a kind of crystal ball. It lets you predict things in the future, like how much money you'll have saved or what your car will be worth, without all the boring work of calculating every single step in between.
So, we've got this amazing power now. We can find any single number in a sequence, no matter how far out it is. But what if we wanted to do something different?
What if we wanted to find the sum of the first 100 numbers? Going back to our ladder, we can predict the height of any single step, but could we figure out the total height of the entire ladder? Now that's a whole different puzzle, and it's exactly what we're going to tackle in our next explainer.